we're going to take a look at fingerprints next. Fingerprints are what's left behind from a mark from the skin ridges found on the palm side of the fingers and the thumbs. There are three main principles we're going to go through regarding fingerprint gathering and analysis and the facts about them. Number one, a fingerprint is individual because no two fingers have yet been found to have completely identical ridge characteristics. Principle number two is that a fingerprint will remain unchanged during an individual's lifetime unless there's trauma to the deep skin layers underneath it, and that fingerprints have general ridge patterns that can allow them to be classified. So principle one, the study of a fingerprint is really done by looking at what's called the minutia, the really small details, the fine details of the fingerprint. It's the identity of those minutia, the number, and the relative location that makes one fingerprint individual from another. In any average fingerprint, there are about 150 minutia. In order to determine that two fingerprints are identical to one another, that they match, there's no predetermined minimum number of friction ridge characteristics that are used to establish positive identification. It really just has to be a point-by-point comparison to prove the identity of an individual. So in trial, it's just, the more the better. With principle two, just the physiological basis of fingerprints, the epidermis is the outer layer of skin, the dermis is the inner layer of skin, and in between those two layers, we have the dermal papillae, and that's where the fingerprint resides. So the dermal papillae is responsible for determining the form and pattern of the ridges on the surface of the skin. And again, those will, without any sort of injury or scarring, those will remain unchanged. They'll get bigger as a person grows, but other than that, they will stay the same. Each skin ridge has pores leading to sweat glands, and then perspiration and oils that have been picked up by touching other areas of the body is transferred onto that surface, and that leaves the ridge pattern or the fingerprint behind. The reason that we have fingerprints, they help increase grip and resist slippage as we grasp objects. The same sort of rationale behind that is found with the concrete surfaces that we drive on, the roads. They purposely draw lines, rake lines, little indentations into the concrete so that water will flow into those little channels, and it increases the grip between our tires and the road. Fingerprints are divided into three classes. You can remember the acronym LAW: loops, arches, and whorls. So we're going to go through the loops first. The loops are most common. These ridges enter and exit the same side of the fingerprint. If the loop opens towards the little finger, it's called an ulnar loop. An ulnar loop. Little finger, ulnar loop. If the loop opens towards the thumb, it's called a radial loop. All loops have to have a delta. The Greek letter delta is represented like this, a triangle, and that's what you see here. Little delta here, triangle here, the delta here. The ridge point at or directly in front of the point where these ridge lines kind of come together and they form a triangle. So all loops have to have one delta. Whorls are the spirals. There are 4 different groups: plain, central pocket, loop, double loop, and accidental. Whorl patterns have a minimum of 2 deltas each, so I'm going to kind of put those in here. There's the 2 deltas in this general whorl. Central pocket loop has a delta kind of in the middle of the whorl. A double loop whorl has 2 deltas there. And then an accidental, just the central core of the whorl kind of looks messed up. But again, we have the 2 deltas there. Minimum of 2 deltas with a whorl pattern. Plain whorl and a central pocket loop have at least one ridge that makes a complete circuit, so goes around in a complete circle. The double loop is just like it sounds, 2 loops combined into one fingerprint. And an accidental contains 2 or more patterns, or is it just this kind of catch-all category of a whorl. Finally, arches are the least common. Less than 5% of known prints are arches, and they're distinct groups only number 2. Two distinct arches, arch types, the plain arch and the tented arch. The plain arch, the ridges enter from one side and exit on the opposite side, like a wave. The tented arch is similar, except there's a sharp spike. The ridges meet at an angle that's less than 90 degrees. So let's take a look at some of those. Another important thing to know about arches, they do not have deltas. So what we see here, there aren't any deltas. Here's a plain arch right here. The ridges come in and exit opposite sides. Same thing with the tented arch, but you see this sharp peak right here in the middle. So again, arches do not have deltas. Fingerprint classification systems are looked at first by using these 3 main fingerprint patterns. They're paired up, one finger in the numerator of a fraction and the other in the denominator. The presence or absence of a whorl pattern is the basis for the determination. So we're looking primarily at the whorl pattern for this primary classification. If a whorl pattern, so we're going to be working with this for each of us as you're creating your fingerprint catalogs. If a whorl pattern is found on any finger of the first pair, so the thumbs, it's assigned a value of 16. The second pair would be the index fingers. The whorl would be given a number 8. On the third pair, it would be a 4. On the second pair, a 2. And on our pinky fingers, a 1. Any finger having a loop or arch is assigned a 0. So the values for all 10 fingers are obtained, they are totaled, and 1 is added to both the numerator and the denominator. The fraction obtained is the primary classification. About 25% of the population falls into the 1-1 category, which means all their fingers have either loops or arches. It's pretty rare. It's important to know that this classification system can't identify an individual on its own. It can provide kind of a narrowing of the field, narrowing the number of candidates, and those have an indistinguishable set of prints in the system's file. Then we have to look at the minutia of each print. APHIS is the database that is used, the fingerprint database. Fingerprints are scanned and digitally encoded. It aids in classifying and retrieving fingerprints. It's converting the image of a fingerprint into digital minutia that contain data about 2 specific minutia. Points of termination, which are called ridge endings, and then they're branching into 2 ridges, bifurcations. So those are 2 minutia that are looked for mostly in classifying fingerprints in APHIS. After the search is complete, so much like the classification system, after the search is complete, there's a list of file prints that have to be examined by a fingerprint expert. So there still has to be that human oversight. Now, how are we going to get prints from a crime scene? Visible prints are easily seen. Blood, paint, grease, or ink are on the person's hands, and it's a transfer to another surface. Plastic prints are also visible. Plastic prints are left in a soft material, so it's more of a three-dimensional print when they're impressed into putty wax, soap, or dust. Locating visible or plastic plastic prints at the crime scene is not a big deal for the investigator because they're usually distinct and visible to the eye. Latent prints will be left behind after a person touches a surface and those body perspiration or oils present are left behind. These are not visible to the eye, and they're commonly referred to as latent or invisible fingerprints. They have to be developed. Latent prints can be deposited on hard and non-absorbent surfaces like glass, mirror, tile, and painted wood. These are called non-porous, and you can dust those using a powder. Prints on porous surfaces like paper, cardboard, and cloth have to be treated with a chemical. And there are various different chemicals that are used on porous surfaces: iodine, fuming, ninhydrin, and physical developer. Superglue fuming is used on non-porous surfaces. The cyanoacrylate ester is what interacts with the fingerprint. It can be accomplished using a fuming chamber or a handheld wand. And it, again, develops latent prints on non-porous surfaces like metal, electrical tape, leather, plastic bags, glass. Development occurs when fumes from the glue adhere to the print, and this will produce a white latent print. Once located, the investigator can develop the print as appropriate. So there are powders that are available in a variety of colors to create contrast. They can be applied with a brush or a magnetic wand, and they adhere to perspirations and body oils of the print. Once it's been visualized, it has to be permanently preserved. So once a visible, a plastic or a latent print has been visualized, a photograph has to be taken before anything else is done, because then that is, again, preserved in case analysis destroys the print. If the object with the print on it is small enough to be transported without destroying the print, it should be preserved in its entirety. I guess we're going to go from here. Hold on. Whoops. Prints on large immovable objects will be lifted using adhesive tape. That tape is placed on a labeled card that provides, again, a good background contrast with the powder that's been used to develop it.